Good morning, everyone. Let's give it just another minute. Hi, Carrie. Give it one more minute to a couple more people in. Hope you're all doing well. This rain is killing my psyche. I need the sun to come out at some point here. It's just been nonstop. My daughter is like losing it. I need to get her outside. I think we're going to get some decent weather this week, though, and it's supposed to go back up into the 50s. So I will take that. So where we left off. So we have been going over compounds, how to write compounds, how to name compounds, how to write formulas, all that fun stuff. We have stuck only thus far with ionics, which means we have a metal combined with a non-metal. We've done a couple different things, predictable charges, unpredictable charges, polyatomic ions. So I want to start class off by just giving you guys a bunch, like 5 to 10, depending on how many I can come up with, practice problems so that you can refresh all that stuff, and we'll go over them. But just so that we can remember what we did last week, because don't you feel like sometimes you'll learn something and you're like, oh yeah, I got it. And then like 4 days pass and you're like, I don't even remember talking about that. Like, what? At least I feel that way sometimes. Okay, so I'm going to mix them all together, everything that we've done thus far. So MgOH2. So the first 5, I want you to write the name. The second 5, I will have you write the formula. Let me move this over a little bit. So we've got MgOH2. We've got Fe2O3. Li2S. ZnSO4. And CON2. Let me make that 2 a little better. All right, so 1, 2, 3, 4, 5. Those are going to be formula to name. Now let me give you some names, and I want you to, you'll then write the formula. So let's see. Aluminum nitrite. Copper 3 carbonate. Silver, whoop, just wrote the symbol for you. Silver, phosphide, IDE. Let's do titanium 1 chloride. 5 calcium nitride. Okay, so that should give you all a decent amount of work for, I'd say, at least 5 minutes, maybe 5 to 7 minutes. Notice which side you might like doing better. Sometimes people like doing these ones better. Sometimes people like doing these ones better. The ones you like doing better or feel easier are the ones you need to practice less. You need to work on the other direction. So I'll give you all a couple minutes. If you have any questions while you're working on these, I'm going to be sitting here. So just put it in the chat. I can write you a message back, and then do know we will be going over all of them together. Anyone having trouble reading any of these? I know that my handwriting can be sort of crappy. Okay. Give y'all 2 more minutes. All right, wrap up whichever one you're on. Okay, so next to each of these, I'm gonna just write a little note. I mean, I know what these all are, but just so that you guys, if you rewatch these videos, so you always want to be identifying like, what is it? Is it ionic or molecular? What is it, a type 1? Is it a type 2? And are there any polyatomic ions? Because that is going to have an effect on how you name. So this first one here, this is ionic. Oh, it's really dramatic. Okay, it's ionic. And is it a type 1 or a type 2? Well, Mg is a predictable charge. So I'm going to put an I with a 1 next to it. Okay, I-1, so type 1 ionic. I'm going to put a little comma here, and I'm going to add a P. The P is for polyatomic ions. So there's also a polyatomic ion in there. So you just need to, be identifying that those are in there. You don't have to necessarily write these on every time you answer one, but it may help. So we've got ionic type 1. So in an ionic type 1, all I have to do is just name the metal. This is magnesium. Because it's a type 1, it has a predictable charge. I don't have to say it's magnesium 2, because when is magnesium ever going to have a different charge than charge 2? It's not. So we just say magnesium. There's a polyatomic ion. So with a polyatomic ion, we just say the polyatomic ion's name. We don't truncate it. We don't cut anything off and add things. We just say whatever it is. So OH is hydroxide. Magnesium hydroxide, and you're done. That's it. This next one here, this is an ionic, but it is a type 2. Okay, metal is iron, unpredictable charge. There's no polyatomic ion, so I don't need to worry about that. So I'm going to start, whenever I do my ionic 2s, I name the metal. So this is iron. I like to put, actually, I'm going to scoot this over so that we can put our charges under there. So iron, I put a parentheses for my Roman numeral. I'll come back to that. And then whatever this second thing is, it's not a polyatomic, it's oxygen. So oxygen, we cut off, and then we add the IDE. So oxide. So we would say that this is in a group of iron oxides. When figuring out the charge, all right, I'm gonna cut this thing in half from my metals and my nonmetals. The whole thing needs to equal 0, right? So oxygen is always a 2 minus charge, and there's 3 of them. So times it by 3. So an overall 6 minus charge here. What does the metal have to be? It has to be a 6 plus charge, but there are 2 of them. So I need to divide it by the 2 to give me a 3 plus. So this would be iron 3 oxide. You can kind of see that the 2 here would be the charge on the oxygen and the 3 here would be the charge on the iron, but you can't always just reverse flip-flop. That works like 75% of the time. Sometimes it doesn't work. So I would actually go through and make sure it's charge neutral. So we've got iron 3 oxide. This next one here, lithium and sulfur. This is ionic. It's type 1. And there's no polyatomic ion. So I'm just going to name the metal lithium. And the nonmetal, which is sulfur. I'm going to cut it off and I'm going to IDE it. Oh, we're getting a letter in there. Sulfide. Okay, the IDE letting us know that it's talking about the element. Next one down here. This is also ionic. And I know that it is sitting in the transition area, but this is going to be a type 1. Why? Because zinc always has the predictable charge of what? 2 plus. So that's just one of the transitions you want to have memorized. And then there's also a polyatomic ion in here. So I'm going to name the metal zinc. Because zinc is always 2 plus, we don't need to fill that in. And then I'm just going to name what the polyatomic ion is. SO4 is sulfate. So zinc sulfate, ATE. This last one here, this is ionic. And it is type 2. No polyatomic ions in this one. So if it's ionic type 2, let's write out our metal, which is cobalt. I'm going to add some parentheses and then whatever the second thing is, in this case, it's nitrogen. So we'll just call it nitride. IDE for the element. We need to go ahead and figure out what the charge is on that cobalt. So let's cut it in half. The whole thing needs to equal 0. Nitrogen always has a 3- charge. How many are there? There are 2 of them. So let's multiply it by 2. So this has a 6- coming from the nonmetal side. So the metal needs to be a 6+. How many of them are there? There's only 1. So we don't need to divide it by anything, or you divide by 1. So the cobalt is 6+. That would be Vi. The V is a 5. The I, or the is symbolizing the 1. When you add those after the V, that's adding them. When the I is in front of the V, it's subtracting. Any questions on those? Is that sparking some memories of last week? Okay, so let's go the other direction. I find this way easier. So aluminum nitride. So you can also give yourself notes here. This is ionic. It's type 1. And nitrite, when I see ITE, that's a polyatomic. Okay, so I'm gonna put a little P next to it. So anytime it's ionic, whether it is type 1 or type 2, you have to balance charges when you're making your formula. The best way to attack this is write the symbol for the metal, Al, and its charge. Aluminum, since it's type 1, aluminum should have a predictable charge. So you're just going to go to your notes on your periodic chart. Aluminum has a 3+. Nitrite is a polyatomic ion. Specifically, it's NO2 with a minus charge. NO3 with a minus charge is nitrate. Okay? From here, we're just going to flip-flop. So if you want, you can kind of group this thing together without the charge. Think of it as a packet. The 3 is going to drop down here. The inferred 1 is going to drop to the aluminum. So I get 1 aluminum for every 3 of the nitrites. Next one is ionic. It's type 2 because it has a Roman numeral. And there's also a polyatomic ion. That ATE at the end, anytime you're seeing the ITE or ATE, it's a guaranteed polyatomic. So write out my metal symbol. Copper is Cu, not Co. What is its charge? If you're like looking at the periodic chart and you think, I can't see the charge. Well, that's what this is. So the charge is a 3+. This is not how many coppers you have. It's what the charge of the copper is. To figure out how many coppers you need, you got to go through the flip-flop. So we've got Cu with a 3+. Carbonate is this thing, CO3 with a 2- charge. Where are you going to come up with that? Reference a polyatomic ion sheet. I'm going to sort of circle this thing again to remind me to keep that as a clump, as a whole. The charge, the 2 is talking about that whole packet. So we're going to flip-flop. So the 2 is going to get dropped down to the subscript of the copper. So it'll be Cu with a 2. And then carbonate, I need to have 3 of them. So I'm going to write my whole carbonate, CO3 in parentheses, and then I'm going to put a 3 on the outside. And I know sometimes that throws people off. They see a 3 and a 3, and they're like, should there be 2 3s next to each other? You can totally have 2 3s next to each other. This number, we want it to apply to the whole polyatomic. Next one here, this is ionic. It's silver, so change that color. Ionic, it's a type 1 because silver has a predictable charge. There's no polyatomic ion here. What is the charge on silver? Silver's charge is always +1. I know it's in the transition metal, but remember aluminum, zinc, silver, down and to the left in the diagonal, 3, 2, 1. Phosphide is talking about phosphorus. So we're going to write P with a 3+. No, we're going to write P with a 3-. Okay. Flip-flop, I should have 3 silvers for every 1 phosphorus to balance it out. Number 4, this is ionic. It's a type 2. Titanium is in the transition, and it also has the Roman numeral, so I know that it's a type 2. No polyatomic ion anywhere near here. So all we need to do is write titanium, which is Ti, with its appropriate charge. In this case, it's a 1. Chloride is talking about IDE, means it's talking about chlorine, minus. That's a 1-to-1. So that would just be TiCl, and you're done. Important thing to note here. Remember when we talked about diatomic molecules and like have no fear of ice cold beer? So like chlorine, nitrogen, oxygen, those guys like to be in 2s when they're by themselves. Sometimes people will say, oh, but doesn't this need to have a 2 here because chlorine likes to be coupled with itself? That is only the case when chlorine is alone, okay? So when you're thinking about your diatomic molecules, are you talking about it by itself or are you talking about it in a compound? If you're talking about elemental chlorine or elemental oxygen or any of those things alone, they will couple up. So for instance, sorry, I'm totally diverting here, but I had someone ask me this question. I think it's a really good question. So are we talking about elemental, let's say chlorine, or chlorine in a compound? If it's elemental chlorine, it's always going to be Cl2. If it's chlorine in a compound, it can have a variety of things. NaCl. How many chlorines are in there? Just 1. CaCl2. How many chlorines? 2. Aluminum chloride, AlCl3. 3. You guys seen how the chlorine number can change when it has a buddy? So it doesn't necessarily have to have the 2 when it's in compound form. When it's in elemental form, make the diatomics diatomic. There's a little footnote there. I had somebody in my 151 class who was like, I don't understand why it's not a 2 here. Only have to 2 it, have to double it up when you're in elemental form. Okay, last guy here, calcium nitride. This is ionic, pretty straightforward. It's type 1, no polyatomic ions. So let's just write the metal, calcium, always a 2+. Nitride is talking about nitrogen. Nitrogen always has a 3-, flip-flop, Ca3N2, and we're done. That pretty much sums up everything we did last week. If you feel good with that, you're like, yeah, it doesn't really matter what you throw at me. I think I've got it. Then you're good with like 80% of the chapter. Okay. What happens when we get into a situation like this, CO2? Non-metal, non-metal, or SiF4, right? Non-metal, non-metal. We don't balance charges. We don't do any of this stuff, and we name it in a totally different way. So all of these are molecular. Right? So let's take a peek. I think the molecular ones are much easier to name. I think if you can get through the ionic stuff that you just did, this will feel hopefully simple. Oh, one thing to note about polyatomic ions, this isn't huge for you guys because you don't have to memorize the polyatomic ions, but one thing to help you. So if your compound has what's called an oxyanion, which is a polyatomic ion with oxygen in it, they come in a series. So sulfite and sulfate sound really similar to each other, right? Nitrite and nitrate. How are they different? Ites are always 1 oxygen less than the 8s. So if you know all of your 8s, like if you know that nitrate, it doesn't mean that 8 is 3 oxygens, because here 8 is 4 oxygens. It just means that whatever your ite is will always be 1 less than whatever your 8 is. So if nitrate is NO3-, nitrite will be NO2-. The charge stays the same. The nitrogen stays the same. The only thing that changes is you strip off an oxygen. Look over here, sulfate, SO4 with a 2- charge. Sulfite, SO3, still has the 2- charge. Okay, so that's one way to kind of learn the series. Here are some expanded out. So let's look at chlorate. Chlorate is ClO3-. If you know that that's chlorate, chlorite would just be whatever chlorate is minus 1 oxygen, so ClO2-. There are two other sets in the series. Let's say we're at chlorate, ClO3 minus, and we add an oxygen. I'm sorry. We go to 4 oxygens, we add the prefix per. So we take the chlorate and we put per in front of it, perchlorate. What if we are at chlorite? So we're at 2 oxygens and we want to subtract 1 oxygen to ClO minus. The next in the series, you'll take the chlorite and you'll put hypo. Have you guys heard of like hypoglycemic, right? Under, below. So that's 1 oxygen lower. So that's sort of the set of oxyanions. You can see the same thing happening here with bromate, right? So if we want to subtract to bromite, we strip an oxygen. If we want to subtract 1 more oxygen, hypobromite. If we want to add an oxygen for bromate, we go perbromate. So that's, I don't do a whole lot of testing. You won't really see me using hypos or pers, but it's a nice way to pair your 8s and your ites together. All right. So let's leave polyatomics and ionics and move into molecular compounds. So what is a molecular compound? It's something that's made of 2 nonmetals that doesn't have a charge. Okay, so this SO4 2 minus, this would not be a molecular compound. We would say that this is a polyatomic ion because it has a charge. If instead I was to write it like this, SO4, and there's no charge on it, these are 2 different things. This would be a polyatomic ion. This would follow this set of rules, okay? So first step is determining that it's a molecular compound. It's made of 2 nonmetals. You're going to insert a prefix. There's nothing about charges here. So don't do anything with flip-flopping, no charge neutrality, nothing like that. You're going to take the name of the first element and you're going to put a prefix in front of it that tells you how many of them you have. Then you're going to take the base name of the second, you're going to ide it, and you're going to put a prefix in front of it that tells you how many you have. So if I write this, CO2, I'm sure you already know what that is, but that is carbon dioxide. Okay, the di being 2. The prefix on the first one, mono, can get dropped. I'll show you that in a second. So here are the prefixes. You want to know them or have them accessible. 1 is mono, 2 is di, 3 is tri, like a tricycle, 4 tetra, like a tetrahedral, 5 penta, pentagram, 6 hexa, hepta, octa, nona, deca. You're not going to see anything past 10. This has nothing to do with charge. It has to do with how many of each you have. There is one exception where you can drop a prefix, okay? You can drop, if the first thing only has 1, you don't have to say that this is monocarbon dioxide. We would drop the mono and just call it carbon dioxide. If there is 1 on the second one, you have to say that. So let's do a perfect example of that. Instead of CO2, let's do CO. Following the system, this would be monocarbon monoxide. We ditch the mono on the first, we don't ditch it on the second, so it becomes carbon monoxide. You don't ditch dis or tris or anything on the first. The only time is if there's 1 on the first, you can let it go. If you have like double vowels, like mono ends with a vowel and oxide begins with a vowel, you can drop the O to combine it to make it monoxide as opposed to monooxide. Are there exceptions to that? Always. So one thing you don't want to drop is like dioxide. When you have 2 oxygens, you wouldn't call it doxide. And triiodide is actually 2 I's next to each other. I'm not super anal about those, but the mastering chemistry can be kind of persnickety. So just make sure you're using the correct balls. So there are, for a lot of these things, there are everyday names, and then there are the systematic names. I don't expect you to have the everyday names memorized. So this one here, N2O, which is laughing gas, we would call this dinitrogen monoxide. Dinitrogen monoxide. Two nitrogens and one oxygen. That's it. Doesn't that feel much easier? Like that's literally, that's all the slides on it for the section. Let's practice though. So when you're writing these two, the more metal-like thing will be listed first because we're dealing with two nonmetals. So like P3 Cl4. The P is going to be listed first on here because phosphorus is closer to the zigzag line. So when naming this thing, I don't flip-flop. I don't do any of that. I just look at phosphorus. There's 3 of them. And what I see pitfalls here is students want to take this 4 and somehow bring it over to the P and the 3 to the Cl. Do not do that. That is for metals and nonmetals. For this one, it's as simple as how many phosphoruses do I have? I have 3. So try phosphorus. How many chlorines do I have? 4. The prefix for 4 is tetra. Tetrachloride. Triphosphorus tetrachloride. This make you sound very, very intelligent around your friends and family. So, that's it. Let's do a couple of them. I'm going to give you some going in this direction and then some going in the other direction. So NO5, C2S2, BR7, F5, Si3O. All right, so write the name for those, and then I'm going to give you the name of a couple over here, and I want you to write the formula. So dioxygen trifluoride, dihydrogen monoxide, heptanitrogen triiodide, and octaphosphorus nonachloride. Sorry, this here should be like one word. So I'm going to give you just 2 minutes on these because they're much faster. Sarah, yes, that's correct. 10% per day. No worries, Sarah, it happens. Okay, so for these ones, this over here, we want to write a name. So the first thing we've got is nitrogen, and there's only one of them. There's an inferred one there. If there's one on the first, we can drop the mono. So I'm just going to say that this is nitrogen. And then the second thing, this is a 5. So I have 5 oxygens. So pent oxide would be one where we drop the A. If you put it as pentoxide again, you'll be okay. I'm not going to test you. Like, it's not going to be a multiple choice for one of these, and one has the vowel and one doesn't have the vowel. This here, C2, S2, I picked this one because both of them have 2. You do not reduce in molecular, okay? So I'm not going to cut those down to 1 and 1. So if there's 2 and 2, I need to say that there are 2 and 2 of each. So dicarbon, disulfide. Okay, make sure you include prefixes even if they're the same. This one here, these are some bigger prefixes. 7 is hepta. So heptabromine. Pentafluoride. Last one here, we've got silicon, and there's 3 of them. So trisilicon. Don't IDE the first guy, keep that as the same. Monoxide. We do mono on the second. Questions on that? Is that sort of a breath of fresh air after all that like flip-flopping of charges? Maybe not a breath of fresh air, but it's a little simpler, hopefully. Let's look at these ones. So you're given the name and you need to write a formula. So we've got some prefixes here. Dioxygen, that's not talking about its charge, it's telling you how many oxygens you have. So oxygen, I have 2. Fluorine, I have 3. Dihydrogen monoxide, H2O, this is water. Right, that's the systematic name of it. Heptanitrogen triiodide. Hepta is 7, so we've got 7 nitrogens. And we've got 3 iodines, I with a 3. Octaphosphorus nonachloride, big molecule here. So we've got phosphorus, octa being 8, chloride, which is chlorine, and we have nana, which is 9. One thing to note, SO3 2- versus SO3. This here, I'm going to call this sulfite, okay? Polyatomic ion. This here, no charge. So I'm going to actually call this thing sulfur trioxide. Okay, molecular. And yes, this is also molecular. It's two nonmetals, but there's a predictable charge coupled with it. And I know sulfite is always going to be in this ratio. If we don't have the charge and it doesn't specify it's sulfite, I have to let the reader know how many of each there are. All right, so don't get those mixed up. Questions on molecular? Nope, nothing. Okay. So it gets a little trickier when they're all jumbled together, right? When you've got some of these combined with the metals, combined with the predictable and unpredictable charges. So the best thing you can do is always start off, is this molecular? Is it ionic? Is it predictable charge? Do I need to do charge neutrality? Are there polyatomic ions? Kind of asking yourself all those questions. There is one more section to the naming that we want to go over. So, and again, this flow chart at the very end is really nice. You may even want to print it out or just have access to it, but it tells you, okay, you start up at top. Is it ionic? Is it molecular? Or is it an acid? And we're going to do acids next. If it's ionic, is it type 1 ion, or is it type 2? From there, it tells you, you go down, you name the metal and the base name, and you IDE it. If it's unpredictable or type 2, you have to add the Roman numeral. If it's molecular, you don't do anything with this. You do prefix this. Final section here, acids. So an acid for right now, your definition of an acid is going to be that you look at the formula and H is the first thing written with one or more nonmetals. So when you take an acid and you dissolve it in water, you will get hydrogens floating around and then some sort of nonmetal. The hydrogen is what makes something acidic. So HCl, H2SO4, H2S. All of these are acids. What's the first thing that you're seeing? Some sort of hydrogen. Could be one hydrogen, could be two. This is a diprotic acid. There could be three. But that first thing you bump into is hydrogen, and then it's mixed with something that's a nonmetal. We can categorize acids as being either binary acids or what are called oxyacids. This is a binary acid. This is also a binary acid. Okay, a binary acid, binary, like binary star system, it's made of just two different things, hydrogen mixed with one nonmetal. An oxyacid is an acid that contains a polyatomic ion with oxygen in it. So this would be an example of an oxyacid. So when naming any sort of acid, you first want to decide, is it binary or is it an oxyacid? So here's our flow chart. Well, first you have to determine it's an acid. So if H is the first thing that's written, it's an acid. Then binary contains only two elements. Oxyacids contain some sort of oxygen polyatomic ion. If it's binary, this is how we're going to name it. You write the word hydro. That kind of encompasses the hydrogen. You take the base name of the nonmetal, you cut it off and you ick it. I see it. And then you write the word acid. So it's most abundant basic acid we see all the time. This thing here, HCl, hydro, chloric acid, hydrochloric acid. Okay, this is one word actually, sorry guys. So hydrochloric acid smushed together. HBr, hydrobromic acid. H2S is a little different. We don't call it hydrosulfic acid, we call it hydrosulfuric acid. Okay, you use the full name of sulfur, just how it goes. Those aren't too bad to name. So I want you to name real quick, H3P. Okay, so following our system, first we decide it's an acid. Yes, the hydrogens are coming first. Is it a binary acid? Yeah, it's just hydrogen with phosphorus. So then we want to name hydro, phosphoric acid. Hydrophosphoric acid. What if it's got an oxyacid? Or what if it's an oxyacid and it has a polyatomic ion? So let's say we've got this thing here, HNO3. It contains the nitrate ion. This H2SO3, this contains a sulfite ion. H2SO4, that contains the sulfate ion. It does matter what type of ion is in there. Specifically, is it ending in ATE? Is it an 8 or is it an ite? If it's an ite, ites will turn into us. Eights will turn into ick. So you take the ite off and you write it as us, acid. You take the 8 off and you write it as ick, acid. Sometimes you can remember it by thinking, I ate something icky. So let's do an example for each of these. HNO2 versus HNO3. So this is nitrite, right? And this is nitrate. So I'm going to take the base name of the oxyanion, so that's the nitr, and I'm going to us it. So nitrous acid. Notice how there is no hydro. It's not hydronitrous acid. We don't do hydro with polyatomics. So just leave that off. This one here, this is 8. I ate something icky. So this becomes nitric acid. So the next slide shows us some of the truncations. So ite, nitrous goes, or nitrite goes to nitrous, nitrate goes to nitric. Sulfite, you write the whole sulfur, sulfuric acid, sulfate, sulfuric acid. Ites, us, ates, ick. Again, none of these have hydro in front of them. So we don't use hydro with oxyacids. We just use the hydro for the binaries. Any questions on those? Okay, so this is, again, super, super useful. I am going to give y'all a couple things jumbled together. And I want you to name them using whatever system is appropriate for what it is. So C3CL4, Al2, S3, CO, N, H2. NO3. No, actually, that last one, sorry, it should be HNO3. And NABR. Okay, so go ahead and name those using the appropriate system, whatever it happens to be. All right, so all kind of jumbled together. So I think the most important thing, people will get the system, but they will mix up rules. So you got to ask yourself, what is this? So this first thing, this is molecular. So no need for flip-flopping. This is just prefixes. Tri, carbon, tetra, chloride, and you're done. Second one here, ionic, because this is a metal and it's type 1. So I don't need any Roman numeral. I'm going to say aluminum, sulfide, IDE, the second guy. This one here, this is ionic, but this is a type 2. Unpredictable charge, no polyatomics. So I'm going to say cobalt, Roman numeral, nitride. Let's get the charge on the cobalt. In this case, nitrogen is 3-. There's only one of them. Cobalt has to be 3+ to balance it out. So this is cobalt. 1, 2, 3. Cobalt 3 nitride. Next one here, this is an acid. And it's not just an acid, it's an acid with a polyatomic ion. So I don't use hydro. I take whatever the polyatomic is. This is nitrate, and I've got to change it. So 8 icky. So nitric acid. Last one here, this is ionic, and it's type 1, and it's binary. It's super easy. We're just going to call this sodium bromide. So any questions on that? That's pretty much all of chapter 5. We will be doing more practice with it, and I might start to lecture a little bit ahead on Thursday since we are a little ahead as a class. But I want to make sure that you guys feel confident in all of that. At least confident enough to study for it. If in any of those you're like, where did this come from? Where are these numbers coming from? What is happening? Why is it doing this? Please let me know. Carrie, what's up? You can just turn your mute off.
On the experiment 7 nomenclature lab, it has the beginning part of it is the atom and the valence electrons.
Don't worry about that. Yeah. Thank you for bringing that up. So on the lab, the first part where it talks about valence electrons in your lab manual, just skip that section because we haven't done valence electrons yet, and we won't do it till chapter 9. So it's just more work than it's worth. We don't even need to do that first section. But do the second 2 matrices on that page. So the ones where it like combines a metal and a non-metal, do all those. Okay, but you can skip the valence electrons. Other questions from anybody? Okay, well then we're gonna finish 15 minutes early today. So if you have any private questions, or you know something about class today and you just don't want to ask it out loud, with other people, that is fine. Stay around. Otherwise, I will see you all on Wednesday. So enjoy the rest of your day. Bye-bye, people.